Today, we are looking a little bit more at concentration and how do we deal with concentration problems where the units aren't actually what we want to start out with. So, what do I mean by that? What I mean is sometimes our units are different than what are required according to the formula for like molarity. Okay. So, because of that, we have to convert the units in order to represent that concentration in that unit. So I think it's a little bit easier for me to explain if I show you with this first problem. So it says a solution weighing 3,500 kilograms was found to contain 18 grams of calcium carbonate. What is the concentration of the solution in parts per million? So it says it's a parts per million question. So my formula for that is ppm, parts per million, is equal to the grams of solute divided by the grams of solution times 10 to the sixth. Now for my solute, I've got that it's 18 grams. There's no problem there. However, for my solution, it says it weighs 3,500 kilograms. Okay. And this is the problem here because parts per million only works because we have an agreed upon value. So we can't just leave it as kilograms. We need to convert it. So we're going to set up a T-chart. So we've got 3,500 kilograms. Okay. Just like all the other T-charts, whatever unit you start with, that goes on the bottom right. G didn't end up looking very good. On the top right, we're going to put the unit we want. We need it in grams. So I'm going to put a G right here. Now I need the relationship between grams and kilograms. The good news is this is a very well-established relationship because in metric, 1 kilogram is 1,000 grams. So we got to multiply this out because kilograms is going to cancel. So 3,500 times 1,000, that's going to be 3,500,000 grams. Okay. And because this is a parts per million question, I'm going to go ahead and look ahead and I'm going to convert this into scientific notation. Okay, so now I have my grams of solution. And I've got my grams of solute, so I can plug them in now. Parts per million is equal to 18 grams CaCO3 divided by 3.5 times 10 to the 6th power grams times 10 to the 6th. Because I have 10 to the 6th on the top and the bottom, I can cancel these out. So all I'm left with is 18 divided by 3.5. So for my answer, I get 5.14 parts per million CaCO3. Let's look at another example of this. It says, what is the molarity of an aqueous solution containing 200 grams of glucose in 1.5 liters of solution? So this is a molarity question. So molarity is equal to moles of solute divided by liters of solution. Now my volume of my solution is in liters, that's good. But my solute is in grams. And that's a problem because I need it in moles. So in order to use molarity properly, I need to convert 200 grams into moles. So I need the molar mass here. So let's calculate it out. Carbon, hydrogen, oxygen. Carbon is 12.01, hydrogen is 1.01, oxygen is 16.00. There's 6 carbons, there's 12 hydrogens, there's 6 oxygens. That's 72.06, that's 12.12, that's 96.00. Put it all together, and we get 81018. 180.18. Okay, now I need to use this molar mass to convert my grams into moles. So 200 grams C6H12O6 divided by whatever unit I've got right here goes on the bottom right. And on the top right, I put what I want, moles C6H12O6. 1 mole is equal to the molar mass, 180.18. Cancel my units. So I'm left with 200 times 1 divided by 180.18. So plug that in. My answer is 1.11 moles C6H12O6. So I now have my moles of solute, and I have my liters of solution, so let's plug them in. So molarity is equal to 1.11 moles C6H12O6 divided by 1.5 liters of solution. Type that into a calculator, and I get molarity equals 0.74 moles per liter glucose, or more commonly, 0.74 molar glucose. Okay. Let's look at one last problem here. What is the molarity of an aqueous solution containing 150 grams of calcium chloride in 625 milliliters of solution? So it's a molarity question. I know molarity is equal to moles solute over liters of solution. It says I have an aqueous solution containing 150 grams of this, so my solute is in grams. I'm going to have to convert that in 625 milliliters of solution. So my solution is in milliliters. I need it in liters, so I'm going to have to convert that too. Okay. So let's start by dealing with the solute. I've got grams. I need moles, so I need the molar mass. So we've got calcium, we've got chlorine. Calcium is 40.08. Chlorine is 35.45 times 1 times 2, 40.08, 70.90. Add those together, 9.011. 110.98 grams. Okay, so 150 grams CaCl2. Copy my unit down. Put the unit I want on top. 1 mole is 110.98 grams. Calculate that out. And I get 1.35 moles CaCl2. There's the first part. Second part, I've got 625 milliliters. Copy my milliliters unit down, copy my liters unit on top. This is also an established metric relationship. It's 1 liter is 1,000 milliliters. Cancel out milliliters. You get 625 divided by 1,000, which is 0.625 liters. So now I've got my moles of solute, my liters of solution. Let's plug them in. Molarity is equal to 1.35 moles CaCl2 divided by 0.625 liters. Plug that in, and we get 2.16 molar CaCl2.